I have a rule on my teams. It is a harsh rule, but it keeps us in business. If your code works perfectly on the first try, I absolutely do not trust it. Juniors write code for the happy path, where the API is always up, data is always clean, and the server always has memory. Seniors, we write code for the war room, where everything is on fire, the API is rate limiting us, and the CEO is calling us asking, why is my dashboard blank? If you're following my 2026 roadmap, you know that the ETL monkey is dead. Today, we're going to bury him in the ground. I'm going to show you the difference between a script that gets you rejected and a system that gets you hired. Fair warning, I'm going to be deleting a lot of code that you think is good. Look at this. This is what 90% of you are sending me in your portfolios. It imports pandas, reads a CSV, does some transformations, and loads all that data into a database. Here is your smoking gun. You wrap the whole thing in a try except block because you didn't want the script to crash, and you think that it made it robust and dynamic and kept red flags from popping up. Guess what? You didn't. You made it lie. If the schema changes, this script silently errors out. The pipeline stays green, the dashboard stays up, and for 3 weeks, we report inaccurate numbers to the board of directors. When we audit that, we find that we missed $50K in revenue because that script swallowed the error. I don't blame the script, I blame the engineer who was too scared to let it fail. This is ostrich coding. You are burying your head in the sand in your production environment. I need you to crash. I need you to crash loudly, and I need you to crash right now. Let's refactor this. We're going to move from scripting to software craftsmanship, right? This is pillar 1 in that roadmap. Step 1, kill that try except block. Unless you have specific recovery plans for specific errors, like a 429 retry, then let that burn. I want to see that trace error so that I can investigate it and track everything back to where the error actually occurred, and then maybe quarantine that data. There are some advanced ways that we can use some try except and things like that, but that's something we'll get into later on. So step 2, defensive types. Stop treating data like a generic blob. Define what the data should look like. If the revenue column contains a string, I want to fix that. I want the pipeline to reject it right now so that I know that it's there and I can go out and fix it. That is anti-fragility. Step 3, structured login. Stop using print error happened. This is useless to me at 3 a.m. Use the logger. Give me a timestamp. Give me the module. Give me the actual payload that caused the crash. And send me all that in the alert and in the email that I'm getting. Now, here is a piece that separates tutorial watchers from hireable engineers. You might write the tests. You might have the best pedantic models in the world. If you're relying on memory to run them, then you are a failure. In a real engineering team, I don't have time to pull down your branch and run your tests for you. I don't trust you to run them either. I trust bots. Automate your tests. This is the automated gatekeeper. It's a CI/CD pipeline where every time you push the code, this bot wakes up, spins up a container, installs all your dependencies, and then runs your tests. If your code coverage drops, reject it. If a unit test fails, reject it. If your linter finds a syntax error, reject it. I don't even see your PR until that bot gives it the green checks. And if you want to impress a hiring manager, don't just show me the code. Show me the workflow that protects that code. Show me the GitHub action that blocks you from merging just garbage into our production repo. Why does this even matter? Why am I yelling about unit tests and GitHub actions? Well, because code to cache. When a script breaks in production, it costs money. If it breaks silently, like junior scripts often do, it costs us reputation and trust with the business that is hard to earn back. It takes years to fix that trust. If it breaks loudly, like senior scripts, it costs us 5 minutes of debugging time as long as you followed all these rules that we just covered. I'm not paying you to write code. I'm paying you to manage risk. If you can't prove to me that your code is safe, I can't afford to let you touch my data. When I was 15 and working at Taco Bell, I made a decision and was told, we don't pay you to think. Well, this isn't that type of job. I'm paying you to think. If you can't or won't, then data engineering is not the place for you. Here's your homework. Take that portfolio project that you're so proud of, the one that you put out on your resume, open it up, delete every try except block that silences those errors. Write one unit test that forces the code to fail on bad data. Then create a GitHub action that runs the test automatically every time you push your code. If you can't do that, you're not ready to move on to phase 2, where we talk about AI infrastructure. Because if you can't govern a CSV file, you definitely can't govern a neural network. Now get out there and get to work, then come back for phase 2.